Hey guys, welcome to your last couple days of learning here. We're gonna kind of finish up this section and we'll do the next section tomorrow and that'll be about it. So today we're gonna finish up with the last objective of section 4, which is rationalizing denominators by using conjugates. So remember last week we talked about you can't have a radical in the denominator for your final answer. So we're going to finish that up with, well, what if you have more than just a radical? What if you have a couple of things in there? So to get rid of a denominator that looks like that with a radical, you're going to do what's called multiplying by its conjugate. So the conjugates are very easy. They're just opposites. So 4 plus the square root of 3 and 4 minus the square root of 3, those are conjugates. And the same, here's another example, 7 minus the square root of 37 and 7 plus the square root of 37 are conjugates. So you see, you just change the sign of the term. If you multiply by the conjugate, it's going to get rid of those radicals in the denominator. So it's going to be fairly easy today, just 6 quick examples, and we'll have you on your way. So to get rid of this denominator of 1 plus the square root of 3, you multiply by the conjugate, which is 1 minus the square root of 3. And if you do something to the top of a fraction, or to the bottom of the fraction, you got to do it to the top, to the numerator as well. So let's look at the numerator first. We'll have to distribute 2 times 1 is 2. And we'll have our minus sign. 2 times the square root of 3 is 2 square roots of 3. Okay, on bottom, we kind of have to FOIL that out. So I don't have a ton of room there, but you should be able to follow my arrows. 1 times 1 is 1. 1 times the negative square root of 3 is going to be a negative 1 square root of 3, or just a negative square root of 3. And then distribute the 3, or square root of 3. Square root of 3 times 1 is a positive square root of 3. And then the square root of 3 times the negative square root of 3. So negative. So square root of 3 times the square root of 3 is the square root of 9. But remember, that just is plain 3. So we'll just go straight to the 3. Now we just have a little bit of simplification to do in the denominator. Notice the middle terms, a negative square root of 3 and a positive square root of 3. Those are opposites. They are going to cancel each other out. That's always going to be the case. That's why we multiply by the conjugate. It gets rid of that. So we have 1 minus 3, which is negative 2 for my denominator. On top, those don't combine, so it's still 2 minus 2 square root of 3. And then we just have to look at that answer. Does it simplify? And the answer is yes. There's a couple of things. One, we don't like to have a negative in the denominator of our final answer. And two, you notice all of these numbers are divisible by 2. So we're going to divide each of these by negative 2. 2 divided by negative 2 is negative 1. Negative 2 divided by negative 2 is positive 1, but I don't need the 1 because there's a square root of 3 tagging along. So this all simplifies to negative 1 plus the square root of 3. Which is kind of interesting to think about, because look at what it started. It was 2 divided by 1 plus the square root of 3. It actually is the same as negative 1 plus the square root of 3. It's kind of interesting. All right, so number 2, we'll look at that example. We'll multiply by the conjugate of the denominator. So the conjugate of the square root of 5 minus 1 is the square root of 5 plus 1. And if you do that to the denominator, you have to multiply it to the numerator to keep it in balance. So that means both of these are going to have to be kind of distributed out. So you'll kind of have, I can't really draw all those arrows, so you'll just have to kind of follow my pen strokes. So the square root of 5 times the square root of 5 is the square root of 25, but the square root of 25 is plain 5. The square root of 5 times 1 is 1 square root of 5, or just the square root of 5. Then distribute the 4. 4 times the square root of 5 is 4 square roots of 5. And then 4 times 1 is 4. In the denominator, let's do that one while we're multiplying things out. The square root of 5 times the square root of 5 is again the square root of 25, or just plain 5. The square root of 5 times 1, once again, is 1 square root of 5, or just the square root of 5. Negative 1 times the square root of 5 is negative 1 square root of 5, or just the negative square root of 5. And then negative 1 times positive 1 is negative 1. And then we just got to simplify what we can. Looking at the top, I can put together the 5 plus the 4. That would be 9. And then I can also put together the 1 square root of 5 plus 4 square roots of 5. That's 5 square roots of 5. On bottom, notice the middle will always be opposites. A positive square root of 5 minus square root of 5. Those are opposites. They cancel each other out. Put together the normal numbers. 5 minus 1 is 4. Look at that answer, and none of these numbers are going to be reducible. 4 doesn't go into 9 or 5, and some of them are odd and some of them are even, so there's nothing that divides all of those numbers. So that's going to be the final answer there. Number 3, we just got an example with the variable. It doesn't make it any different. Just multiply by the conjugate. What's the conjugate of 1 plus the square root of x? 1 minus the square root of x. If you do that to the denominator, you must multiply it to the numerator as well. Distribute that numerator, and you'd have 3 minus 3 square roots of x. On bottom, 1 times 1 is 1. We'd have a negative square root of x. We'd have a positive square root of x. And then what's the square root of x times the square root of x? That would be the square root of x squared, or remember, that just cancels each other out. It just gives you x. Okay, and on top, those are not like terms, so we can't put those together. On bottom, look at those middle terms. They're opposites. They'll always cancel each other out. So what's that leave us with in the denominator? 1 minus x. So that answer definitely doesn't simplify because this is a really weird denominator. So that's as far as you can go. So that's as tough as it's going to get today. If you want to pause the video here and try 4, 5, and 6, that would be great. Let's see how you did. Should have multiplied this one by 1 minus the square root of 5. That would be 4 minus 4 square roots of 5 in the numerator. And the denominator, I'd have 1 minus the square root of 5 plus the square root of 5, and then minus 5, because the square root of 5 times the square root of 5 is 25, and the square root of 25 is 5. Put all those together, and you have 4 minus 4 square roots of 5 over negative 4, and much like number 1, all of these are divisible by negative 4, so that would give you negative 1 plus 1 square root of 5, but I don't need the 1 out front. So my final answer is negative 1 plus the square root of 5. Number 5, you should be multiplying by the square root of 3 plus 1. And again, you got to distribute all that. So the square root of 3 times the square root of 3 is 3. The square root of 3 times 1 is 1 square root of 3. 2 times the square root of 3 is 2 square roots of 3. 2 times 1 is 2. On the denominator, the square root of 3 times the square root of 3 is 3. I'd have a positive square root of 3 and a negative square root of 3, and then a negative 1. In the numerator, 3 and 2 make 5. 1 square root of 3 and 2 square roots of 3 is 3 square roots of 3. In the denominator, those are opposites as always, and 3 minus 1 is 2. Again, it doesn't reduce any further, so that would be your final answer. Last one here would be the conjugate is 5 plus the square root of x. Multiply by that to the numerator as well, and that would give you 40 plus 8 square roots of x. In the denominator, 5 times 5 is 25. We'd have a positive 5 square roots of x and a negative 5 square roots of x. And the square root of x times the square root of x is x. Those middle ones cancel each other out as always. The numerators don't go together any further. The denominators don't go together any further. Nothing reduces. So that's your final answer. So not too bad today. Let me know if you do have any questions. I'll be happy to help. We'll talk to you later. Tomorrow will be your last lesson in math for your OCO career. So have fun while it lasts. See y'all later. Have a good one.